Hey everyone, let's do the Unit 2 Lesson 10 practice problems together. And just to make things a little different this time, I've decided I'm going to do the questions like on my screen using the online Desmos rather than the book. So that's a little different. That should feel super normal to the kids in my class because they do their homework online like this anyways. But if you're in Mr. Wong's class, don't worry, the questions on the screen are the same as in the book, so it shouldn't be a big deal. All right, so this is the warm-up, and it says we should select um, all of these equations that are true. So we got to check and see if the expression on the left side uh, evaluates the same number as the expression on the right side of the equal sign in each one. So start with this first one. It says 3/2 times 16, and I'm going to write 16 as 16 over 1 because that just makes like fraction multiplication easier for me to think about. And so that's 3 times 16 is 48, and 2 times 1 is 2. So the left side of this equation equals 48 over 2, and 48 divided by 2 is 24. And so now I just got to worry about the other side of the equal sign. If the other side of the equal sign also equals 24, then we should select this one. So the other side says 3 times 8, which does indeed equal 24. So I would select that one. All right, let me get another color to do the next equation in. So I'm on equation number 2 now. It says 3/4 divided by 1/2 on the left side. And the way I'm going to do this is I like to call it keep change flip, or KCF in my class. A more technical way of saying it would be we're going to change this division operation into a multiplication operation by using the reciprocal of 1 over 2. We can, instead of I spoke right. So instead of dividing by 1/2, we can multiply by 2 over 1, the reciprocal of 1/2, and we'll get the same answer. So multiplication is just an easier to deal with operation. So I'm going to keep the 3/4 exactly as it was. That's the K in KCF. I'm going to change division to multiplication. That's your C in KCF. And then I'm going to flip 1 over 2 to 2 over 1. And now I just multiply. 3 times 2 equals 6. 4 times 1 equals 4. And I can simplify that to, if I divide by 2 on top and bottom, this is 3/2. All right, so now I just need to check and see if the other sides of the equal sign still have that. So I'm noticing something about this equation is it's like a multi-part equation. It has 2 equal signs, so everything separated by an equal sign has to be equal in order for this whole thing to be true. So the next thing I see is 6/4 right here, right? And I already know that that's equal to what I got because that's actually the answer that I got, and I simplified from there. So I'm happy with that one. But then the last one says 1/4. And so in order for this whole thing to be true, 6/4 would have to be equal to 1/4. I wish I would have just noticed that right off the top before I started doing any of the operations here, because 6/4 is not equal to 1/4. There's no way that could make sense. So I would not select that one. And then the last one, let me get a different color to do that one in, says 2.8 times 13 is supposed to equal whatever 0.7 times 52 equals. This feels like it could be equal. I see that the 7 times the 2 here is going to end in a 4. This 8 times this 3 here is going to end in a 4. So they're both going to end in the same number. This is almost 3 times 13. It's about 39, a little less than 52. I'm going to guess these are going to come out equal, but I'm not going to do this math in my head. I'm just going to use a calculator. I thought there would be a calculator button on here, but there's not. So, I'm just going to leave this one up to you. Rather than me finding you the answer, just grab a calculator, do 2.8 times 13, and do 0.7 times 52. If those two things come out to the same number, then you should select this equation. If they don't, then you should not select it or not circle it in your book. I mean, I'm going to guess that they do come out to the same number. All right, so let's move on to the next one. All right, so it says Mia and Jamal bike home from school at a steady pace. So I assume that means that they're going the same rate the whole time. They're not going like fast and slow. Mia bikes 1.5 kilometers and it takes her 5 minutes. All right, so I'm gonna just kind of circle or underline. Oh, I don't have my drawing tool on. I'm gonna kind of just like underline this information in green to just kind of keep track of it. And then Jamal bikes 2 kilometers in 8 minutes. All right, so I'll underline that in red. So everything I do for Mia on the screen will be in green, and everything I do for Jamal will be red. And so it says use the sketch tool to graph 2 lines that represent Jamal's and Mia's bike rides, and then label the lines J and M for Jamal and Mia. All right, well, I'll just keep using green for Mia and red for Jamal. So I already have the red tool out, so I'll do Jamal first. It says he bikes 2 kilometers in 8 minutes. And I notice here that time is on the x-axis and distance is on the y-axis. So I'm going to grab this 8 here for 8 minutes. And I'm going to use that to go to 8 on the x-axis. And then I need to go up to 2 kilometers because that's how far he went in that time. So I can graph this point right here to represent at least some piece of Jamal's bike ride. And then for Mia, I can do the same thing, but it's going to be 5 minutes on the x-axis here. So I go to 5, and then 1.5 kilometers. So that's right here. All right, and so now if I were to draw lines that represent these, I'm going to grab the line tool from Desmos because I feel like that'll make my lines straighter and easier to look at. I'm going to connect this line for Jamal, sorry, Mia's green, but I'm going to make it go all the way. I'm just going to make sure that it passes nicely through that point that I made. And then I'll make another one for Jamal, and I'll make sure it passes nicely through that red point I made. Notice I started both lines at the origin or 0, 0. Logically, that should make sense, right? I think both Mia and Jamal should have gone 0 kilometers in 0 minutes, right? That's what this point represents in this graph, 0 minutes and 0 kilometers. And like, there's no other way that that can make sense, right? There's no way that they went some distance in 0 time, right? That would be some sort of violation of the universe that we live in, I expect. So, so let's look at these lines. I'll label them. It's telling me I should label them. So let's see here. I got my green out, so I should label this line here for Mia on top. And I'll get my red tool out and I'll label this for Jamal. And so just looking at these lines, I noticed that Mia's is above Jamal's. Okay, I also notice that Mia's is a little bit steeper, right? Like she is getting a little bit more distance for the same amount of time as Jamal is, right? In 8 minutes, Jamal went 2 kilometers, but in 8 minutes, it looks like Mia went, something between 2.25 and 2.5. So Mia's going a little bit faster, and I recognize that as Mia's line being a little bit more steeper than Jamal's. Their speed is being represented by how steep this line is. All right, so let's move on to the next one. So now we want to find the value of K for both Mia and Jamal. So they're constant of proportionality, right? Like what number would we take the minutes and multiply by in order to get how far they've gone. So let's see here. Well, I know that this point right here for Jamal, so I'll start with Jamal. This point right here is for Jamal, and it's the point 8, 2, right? 8 minutes, 2 kilometers. Well, this 8 is an x value, and this 2 is a y value, right? Because that's how coordinate points always work. It's an x number, comma, the y number. And so having this 8 as an x value and this 2 as a y value is literally the exact same thing as if you were presented with a table like this and it said, oh, x value's here, y value's here, and then they put an 8 in the x column and a 2 in the y column. And then you would think, okay, well, I know that in order to find k, I'm supposed to do a y value divided by an x. And in this case, I have 2 for y, so I'll put 2 up here, and 8 for x, so I'll put 8 here. So I have 2 divided by 8, which is like some decimal if you like decimals, but I can also simplify it to 1/4, so that's the same as 0.25, right? And so one of the skills that you got to be able to do in these lessons that we've been practicing, right, lessons 8, 9, 10, is taking data from a coordinate point that's an x value, comma, y value, and doing the same things with them as you would if we had a table with x, y values, right? Just recognizing that one represents x, one represents y, we can still divide them to get our constant of proportionality. And so the k for Jamal is gonna be, I'll write 0.25 instead of 1/4, no big deal. All right, so let me do the same thing for Mia real quick. Mia, we had this point right here for Mia. It's kind of mixed in with the A at the end of her name, but it's right here. And it's 5 minutes, comma, 1.5 kilometers. So 5, comma, 1.5. And so same thing. If I had, maybe I had a Mia table over here with 5, oops, I meant to draw that as a, like these are our x values, and these are our y values, and this is, well, 5 minutes for x and 1.5 for y. And so I just need to do y divided by x. Okay, equals y divided by x. I don't really want to have to, well, no, I can divide this decimal. This isn't so bad. I can do this. So 1.5 divided by 5. I think about the fact that if I was just doing 15 divided by 5, the answer would be 3. But since this decimal point is here between the 1 and the 5, so it's 1.5 instead of 15, the answer is going to be 0.3. All right, so each one of these is a constant of proportionality, but it's also a unit rate. A unit rate tells you how much of something you're getting for every one of the other quantity in one of these types of relationships. So in this case, this is telling us that Mia is going 0.3 kilometers for every 1 minute she rides the bike, whereas Jamal is going 0.25 kilometers for every 1 minute that he rides the bike. And that allows us to graph these really important points on the graph. So if we go to 1 on the x-axis, this is where the graph represents what's going on after 1 minute. And so according to these values we just calculated, this point right here on Mia's line should be the point 1, comma, 0.3, because Mia goes 0.3 kilometers in 1 minute. And that point has this like special name that we call it. Sometimes we say 1, comma, k, because you have 1 for your x value, and then whatever the y value is has to be your constant of proportionality or your unit rate. And so another name for this that you see sometimes besides 1, comma, k is 1, comma, r, because the r stands for unit rate. So constant of proportionality, unit rate, doesn't matter which one, just as long as you understand that, oh, if I go to 1 on the x-axis and then look up, whatever the y value is there on the line, that's my constant of proportionality or my unit rate. All right, so I'll get the red one out to do Jamal's 1, comma, k point. So Jamal's k is 0.25. So that means this point right here that's just a little bit below Mia's must be the point 1, comma, 0.25. Right. Let's move on to the next one. I'm going to clear all this stuff off the screen. Wait, no, maybe I shouldn't because it depends on what's on the next part. Let's see. Yeah, so we're still working on the same stuff, so I'm going to keep it for a second. All right, so the last thing they want us to answer is who's biking faster? Well, I already said earlier that it's Mia, right? Mia's line is steeper. She's getting more distance for every minute that she bikes. She has a faster unit rate, 0.3 versus 0.25. So I'm going to click Mia. Not letting me for some reason. Mia. I don't know. I don't know why it's not letting me click. Whatever. Mia's the right choice there. All right. Now I'm going to clear all this stuff off the screen because we got a new problem here. It says that at a supermarket, you can fill your own honey container and pay by the ounce. Okay. If you buy 12 ounces of honey, you pay $5.40. How much does the honey cost per ounce? Okay, so what we're trying to calculate here is, like, here's the magic words that I care the most about, right? Cost per ounce. Cost per ounce. That's what we're trying to calculate right now. And whenever you hear this, like something per something else, cost per ounce, dollars per pound, miles per hour, kilometers per minute was what we were just doing with Mia and Jamal. That's the phrase there, like cost per ounce, is literally telling you the two things you need, right? Cost per ounce tells us we need a cost and we need ounces. And the per could literally mean, like when you're doing math, at least you can sort of read it as divided by. This is literally telling us to do the cost divided by the number of ounces we have. And if we do that operation, then we will get a unit rate. It will tell us how much it costs, the honey cost for every 1 ounce. So that's our goal. Cost of honey for 1 ounce. This is known as a unit rate. It's how much honey can we get for, or how much do we have to pay for 1 ounce of honey. That's what makes it a unit rate, because in this case, the unit is ounces, right? So unit rate. All right, so I'm just going to do the cost, which is $5.40, divided by the number of ounces, which is 12. And so I don't know, I'll do a little long division. I haven't done this in a while. Let's see here, 12 cannot go into 5, so I'll just put a 0 here as a placeholder. I'm going to bring my decimal point straight above so I don't lose it. And now let's see here, 12 goes into 54 4 times. 4 times 12 is 48. If I subtract this down, I get a 6. I'll bring down this 0. 12 goes into 65 times. So 0.45. What this tells us is that you get you need to pay 0.45 of a dollar, aka 45 cents, dollars per ounce. And so the honey costs 45 cents an ounce. Right? So 0.45 would be the correct answer to enter there. Wrong way. And so now it's literally the exact same question, but they're asking us the other way now. Rather than asking us what's the cost per ounce, how much money are we paying every time we buy 1 ounce of honey, they want it the other way. They want to know how much money can you buy for $1. So this is still a unit rate, right? But in this case, the unit is $1. If I have $1, how much honey can I get? How much honey for $1? So this is still a unit rate. It's just the other unit rate, right? In the last question, the unit was ounces of honey. And in this question, the unit is $1. And so we're still going to do a division the same as we did last time, but we're going to divide the other way. Because this time, right here, it says we're looking for honey per dollar. So let's just take the amount of honey we were given. That's 12 ounces. and divide it by $5.40. And so I'm looking at this. This looks like it's going to come out to 2 point something. I don't feel like long dividing this like I did the last one, so I'm going to grab a calculator. I know that the answer should be about 2.5. If I get anything that's too far away from that, I'm not going to be happy. So let's see. I'm doing 12 divided by 5.40, and I get 2 point and then 2 repeating. So here's the thing about that. This is supposed to be a number of ounces, right? We're trying to figure out how many ounces we can buy per $1. If you're working in the book, then you're probably fine. You can just write 2.2 repeating. But if you're working online and you try to enter your answers like 2.22222, I don't know if Desmos is going to mark that right or wrong. Desmos tends to not like when you try to do that. And so you could get around that by trying to enter your answer as a fraction. One way we could do that is writing this 5.40 as 54 tenths instead. So what we're really trying to do is 12 over 1 divided by 54 over 10, right? Think of this as 54 dimes. If you had 54 dimes, you would have $5.40. All right, so I'm going to keep change flip like I did in that previous question. I'm going to keep the 12 over 1 the same, and I'm going to multiply by 10 over 54. And what I get is 12 times 10 is 120 over 54. If you entered that into Desmos, I would imagine it would mark it correct. We could simplify this. This is equal to 60 over 27. I think this can simplify even further. If I divide both top and bottom by 3, I can get 20 over 9. I don't think it's going to simplify any further than that, but that would probably get you a correct answer on Desmos. Sorry. But that's just a weird way of saying it. You can buy 20, so you can buy 20 ninths, or I guess you could say 2 and 2 ninths. That's supposed to be a 9. 2 and 2 ninths ounces for every dollar is what that says. All right, so we've got these 2 unit rates that we just did for these 2 questions. All right, so now they're asking us for 2 equations that represent the two unit rates we just did. So we're still talking about the same honey and money situation, and we're going to represent H, or honey, with H, and the total cost will be C. All right, so H is ounces of honey, and C is the cost. And so here's the 2 unit rates that I calculated in the last 2 slides. Let's just remember them. It was 20 ninths ounces per dollar, right? That's how many ounces you can buy with each dollar. And then I literally forgot what the other one was, and I haven't been typing them in. I've just been clearing my drawings, so I got to think about it for a second. What was the other one? It was, oh yeah, that's right. It was 45 cents, right? So the other one was $0.45 per ounce. All right, so let's put these into equations with H and C. Well, this unit rate here first, I'm going to do the top one first, says that if you're getting 20 over 9 ounces for every dollar, then the amount of honey you can get is equal to 20 over 9 times however much you pay, right? The cost. So that's one equation. So think of it this way. If you, this is supposed to be a 9, it kind of looks like a G or something, 9. If you put a 1 for C, meaning you're paying $1, you'd get 20 ninths ounces of honey. If you put $2 in for C, you would get 49th ounces of honey. The other one is just going to be the other way. This equation here is going to say, okay, well, the cost you pay is equal to 0.45 or 45 cents times however many ounces of honey you buy, which we're representing with H in this situation. All right, so these two equations right here say the same thing, just flipped. Number 8. So it says at a supermarket, you can fill your own honey container and pay by the ounce. It's still the same question, right? It says drag the movable points to graph the line of one of your equations from the previous screen. So let me put my equations here again. Oh, your equations, if you typed your equations in, they'll automatically be there. I haven't been typing them in, I'm just drawing on the screen, so that's why mine aren't there. All right, so I know that if I buy, oh, so I get to pick here. Okay, so I'm gonna make the x-axis the cost, and I'm gonna make the y-axis the ounces of honey. For whatever reason, that's just an easier way for me to think about it. And so I know that based on my equation from previously, the amount of honey you can get equals 45 cents times however much, nope, that's wrong. Sorry, I mixed that up. The cost is gonna equal 45 cents times however many ounces of honey you get. All right, so in this case, actually, if I were gonna use this equation, I should flip these axes. Right, in this case, C is sort of in the position where Y would normally be in our equations, and H is more in the position that X would normally be in. So because I'm gonna use this equation, I'm gonna change my mind. We're allowed to do this. I wanna make this the C axis, and I wanna make this the H axis. But you could do it either way. This is just the way that I'm choosing to do it. All right, so I know that, let's see here, 2 for H makes the cost 90 cents, right? If I put a 2 in for H, then 2 times 0.45 equals 0.90, right? 90 cents. So if I just find the 0.2 comma 90 cents, that'll give me a good point. So you have to kind of eyeball it though, right? This isn't that great. Well, I know that the second line up is $1, right? Because it's right between 0 and 2. So I guess I just wanted a little bit lower than that. Let's see here. What if H was 10, right? I'm gonna buy 10 ounces of honey. Well then, I would have the point 10 comma $4.50, right? 10 times 0.45 is 4.5. So that might help me find another really good point on here. Let's see, 10 comma 4.5. Look, I think I nailed it, because $5 should be this line right between 4 and 6. And so that means $4.50 is this line right here. And my thing looks like it's hitting it perfect straight through it. So I'm gonna leave my line exactly how it is. All right, so this problem says the point 3 comma 6/5 lies on the graph representing a proportional relationship. Select all of the points that also lie on that same line. So I have to find these other points that create an equivalent ratio with 3 and 6/5, right? You get a straight line on a proportional graph because all the ratios are equivalent. As soon as the ratios aren't equivalent, then the points start coming off of the line. So I'm checking for equivalent ratios here. Let's see here. First, I need to find the ratio between 6/5 and 3. So I'm going to do 6/5 divided by 3 over 1 equals, well, I'm doing a key change flip right now, 6/5 times 1 over 3 equals 6 over 15. All right, so now I'm just going to take the y value from each of these and divide them by the x value. If it comes out to 6/15, I select it. If it comes out to anything other than 6/15, I don't select it. So I will do this one first. Let's see here, 0.4 divided by, or maybe this will be easier if I simplify this fraction here. So 6/15 is equal to 2/5, which is also equal to 4/10, right? I'm writing different ways of writing it so I can kind of see what's going on here. So this one, this is 4/10, right? 0.4 is 4/10 divided by 1. That equals 4/10 because any number divided by 1 is itself. So I'd select that one. All right, next we've got 6/10 divided by, this is 1.5, but I'm doing everything in fractions right now, so I'm writing it as 3 over 2. Well, that's the same as 6 over 10 times 2 over 3, which equals 12/30ths, which is the same as 4/10, right? I divided this by 3 and divided this by 3, so I think that one works as well. Okay, next, I see 6/5 comma 3. There's no way that 6/5 comma 3 is the same ratio as 3 comma 6/5. I'm not even going to bother checking that one. There's no way that works. Okay, the next is 4 comma 11/5. So I'm going to take 11/5 and divide it by 4, which is the same as taking 11/5 and multiplying by 1 over 4. Oops, that's supposed to be a 4. And I get 11 over 20. That's not the same as 4 over 10. I'm not going to select that. And the last one is 6 comma 15. So I have to do 6 divided by 15. And look up here, I already had this fraction. In the very first thing, 6 comma 15 simplified to 4/10. So I know this is going to simplify to 4/10. So I would select that one. All right, the last one. It says, a company makes 3 types of rope, thin, medium, and thick. Rope can be purchased in any amount. Each point represents one purchase. For each point, identify whether it represents a purchase of thin, medium, or thick rope. Well, we expect the price to be proportional, right? So if I can connect any 2 points from the origin, then they should be the same type of rope. So in my opinion, A and B must be the same type of rope because they make a straight line through the origin. And in my opinion, it looks like F and C must be the same type of rope. And lastly, it looks like E and D are the same type of rope. And then it makes sense to me that if I'm buying rope, the thin stuff is going to be the cheapest, which is going to be the bottom here, right? Because, let me use this other tool. The thin stuff should be on the bottom because that's going to be the lowest price stuff. And then, oh, well, wait, no. I'm looking at this, now I'm looking at the graph more carefully, and I see that this graph isn't about price. This graph is about length and weight. Okay, so thicker rope should weigh more, right? As you get more length of it, you're going to get more and more weight on a thicker rope. So the ones with the higher slopes, the ones that are going up faster, means you're getting more weight for each length. So that's got to be the thickest one. So the E and the D are going to be the thick ones, and the E and the F, sorry, F and C, I meant, are going to be the medium. So I think I would go A is thin, B is thin, C is medium. Oh, it's going to force me to actually type out medium. F is medium. And then that leaves E and D as thick. All right, that's it. See you next time.